Okay, for part E, we're asked to find the volume by revolving R about the line y equals 8. We're asked first to use the disk method. Okay, so y equals 8 is this horizontal line right here. Revolving it around that way. So, to use the disk method, I chop up the axis that's parallel to the axis of revolution, so that would be the x-axis. And we already know this is going to go up to x equals 2. I draw in my representative rectangle here, and when I swish that around the line y equals 8, I get an honest-to-goodness disk. I don't get a hole, I get an honest-to-goodness disk. So the volume of a representative disk is pi times the radius squared times the thickness. Alright, so I'm going to be integrating. Well, I'm chopping up the x's from 0 to 2. The radius squared is going to be the distance from the axis out to the top of one of these representative rectangles. That's going to be the height of one of these rectangles, which is going to be the top minus the bottom, 8 minus x cubed. Squared times the thickness, dx. And even though we're just asked to set this up, if we were to proceed, what we'd have to do is multiply this out using 8 minus x cubed times 8 minus x cubed, so use your FOIL or whatever you want to call it, and then integrate term by term. That'll do it then for part E. Okay, part F, we're still revolving R about the line y equals 8, but now we're asked to use the shell method. So, instead of chopping up the axis parallel to y equals 8, we're going to chop up the other axis and draw in our representative shell. And remember, the volume of a representative shell is 2 pi times the average radius times the height times the thickness. So we're chopping up the y-axis from y equals 0 to y equals 8. That means the thickness is going to be delta y or dy. The average radius, well, this is where it gets a little tricky because that's the distance from the axis of revolution down to our representative rectangle. So for example, if I'm at y equals 1, I'm 7 units away from 8. If I'm at y equals 2, I'm 6 units away from 8. If I'm at y equals 5, I'm 3 units away. So if I'm at some y value, I'm 8 minus y units away. The height is going to be the height of this representative rectangle, which, once again, we have to solve x in terms of y, which we've done before. That's cube root of y. And the thickness, as we mentioned, is dy. And once again, we would convert this to y to the 1/3, multiply it through before we would then attempt to integrate. That'll do it for part E. Okay, part G, we're revolving R now about the line x equals 4, and we're asked to use the disk method. Okay, so the first thing we have to do is remember, where is x equals 4? This was x equals 2, because remember that's the curve y equals x cubed. So x equals 4 is over here. So I'm revolving it around x equals 4 now. And so what do? We chop up the axis that's parallel to the axis of revolution to get our disks. That means we're going to be chopping up the the y-axis. So I draw in a representative rectangle here. I imagine whooshing that around. I'm not going to get a disk. I'm going to get a disk with a hole in it. Why? Because once again I have this gap here. So this is going to be technically what they call a washer, but we'll handle this the way we handle all these kinds of things. We'll extend this rectangle to the axis of revolution to give us an honest-to-goodness disk, and then we'll subtract off the gap. So this is another hole minus hole scenario. So we extend all the way out to the axis of revolution. And we're going from y equals 0 to y equals 8. Minus the gap. That's the whole part. Now we remember the formula for a generic disk. The volume is pi times the radius squared times the thickness. So V is equal to, I'm integrating, I'm chopping up the y-axis. So the thickness is going to be the dy or delta y, and I'm going from, oops, don't forget my pi, 0 to 8. And the radius, remember, of the disk is the distance from the axis of revolution back to this curve. Okay, now how far is this going to be? Well, this is x equals 4, that's x equals 0, that's a constant 4. So that's going to be 4 squared dx minus pi times, oops, I should do this. Remind us we're chopping up the y-axis here in both of these guys. Going from 0 to 8 once again. And now I need to know the radius of this disk. So the radius of this disk is going to be that much. And how much is that much? Well, from here to here, I need to take the right curve minus the left curve, just like when we were looking at area between curves and we were chopping up the y-axis. So we take the right curve minus the left curve. The right curve is x equals 4. What's the left curve? Well, we've done it before, we're going to do it again. Solve this guy for x. So it's 4 minus the cube root of y squared times the thickness dy. And excuse me back here, the thickness is dy because we're chopping up the y-axis. Alright, so that'll do it then for part G. And finally part H, we're revolving R about the line x equals 4 again, but we're asked to use the shell method. And once again, the shell method has the advantage of having the holes already built into it. So I'm going to be chopping up not the axis parallel to the axis of revolution, but the other one. I draw in my representative rectangle here, and that's going to whoosh around and give me a shell. The volume of a shell, once again, is 2 pi times the average radius times the height times the thickness. And I'm going to be chopping up the x-axis, so the thickness is going to be the dx. So I'm going to be integrating on the x-axis from x equals 0 to x equals 2. The average radius, so the average radius is the distance from the base of this shell out to the axis of revolution. So if I were at x equals 0, it would be 4 units. If I were to x equals 1, it'd be 3 units. X equals 2, 2 units. So if I'm at some x value here, the average radius, the distance, would be 4 minus x to the line x equals 4. What's the height of the shell? That's top curve minus bottom curve, which would be 8 minus x cubed. And the thickness, as we mentioned, is dx. That'll do it for quiz 19.